Guys, we're starting off with some LeetCode. Starting to feel that I'm out of that nice feeling when I first started. I was like, "Oh, I'm ready, let's go!" I was excited. Um, I'm already getting that feeling like, you know, uh, not that I don't want to do it at all. It's just, I'm still practicing on the first three. I should probably start the newest one. Not gonna lie, because that other one. Matter of fact, these are all good to have, but I'm I'm ready for pointers and stuff. I really am. Um, I've been ready for. In fact, I might like try a tree and stuff. Like even though I want to go in order, I need to learn some advanced stuff. I need to like sliding window. Like I need to learn that stuff. But since it's an app, it's a valid anecdote, valid palindrome. Let's do that one. Oh, I ran a canal Panama. It's almost the same thing as an anagram. Almost. Almost. It's almost. I'm not saying that it is. It's just similar. I don't want the video. I want to. I mean, I want the video.
Hey everyone, welcome back, and let's write some more LeetCode today. So today let's solve the problem valid palindrome. I'm actually going to be solving this two different ways, and I think both ways are definitely going to be helpful to know in an interview setting. Before we start, I just want to quickly mention that this problem is actually a part of the Blind 75 list of questions. And luckily, we have actually solved the vast majority of the Blind 75 questions. I even have a playlist of all of these questions in the description if you want to take a look. And of course, we will be finishing one more today, getting one step closer to 100% completion of Blind 75. So we are given a string S. All we want to do is determine if it's a palindrome. If it is, we can return true. If it's not, we return false. Only one catch is that we are only considering alphanumeric characters in the list, and we are ignoring cases. By ignoring cases, they mean upper and lower case. So in the input string, you can see the leftmost character is capital A, the rightmost character is lowercase a. Both of these characters are considered the same. So if we had a string, an input string like big A, lower a, this string itself is a palindrome. So we do return true. Even though one is uppercase and one is lowercase, we are ignoring the cases of the characters. And also, when they say we're only considering alphanumeric characters, basically it means we can ignore everything that's not an alphanumeric character. What is alphanumeric? Basically everything from uppercase A to uppercase Z, everything from lowercase a to lowercase z, and everything from 0 all the way to 9, right? Every character and every digit. So basically in this input string, it might not look like a palindrome initially, but the answer is yes, true. It is a palindrome because, and actually before we even get into that, what is a palindrome if you don't remember? Well, basically the easiest way to check if a string is a palindrome is basically if it reads the same way as it does when it is reversed, meaning if the string is the exact same even after it's been reversed. So for example, A, B, A, if we reverse this string, it's still A, B, A. So it is a palindrome, right? So, and let's take this string. If we reverse it, is it still the exact same? Basically, if we read it in reverse order. And the answer is yes. Let's just compare a few characters initially. Let's start at the beginning, right? A, and remember we're ignoring case, so when I say ignoring case, I'm just going to basically convert it to lowercase, so everything is just going to be lowercase. So we have an A. Okay, next character is a space character, but remember, we're only considering alphanumeric, so we don't even consider the space. We want to skip that space, so just delete it, right? The next character, M, and then next character A, next character is a palindrome, is basically if it reads the same way as it does when it is reversed, meaning if the string is the exact same even after it's been reversed. So for example, A, B, A, if we reverse this string, it's still A, B, A. So it is a palindrome. right? So, and let's take this string. If we reverse it, is it still the exact same? Basically, if we read it in reverse order. And the answer is yes. Let's just compare a few characters initially. Let's start at the beginning, right? A, and remember we're ignoring case. So when I say ignoring case, I'm just going to basically convert it to lowercase. So everything is just going to be lowercase. So we have an A. Okay, next character is a space character. But remember, we're only considering alphanumeric. So we don't even consider the space. We want to skip that space. So just delete it, right? The next character, M, and then next character A, next character N. So we just took this from the beginning of the string, a man, right? So let's start at the end of the string. We have a lowercase a, right? And then we have a lowercase m. Then we have a lowercase a, then we have lowercase n. So even starting at the end of the string, it looks like it's the same as the beginning when we read it in reverse. And it turns out that if we, take this string and remove all the spaces, all the special characters, and then convert everything else to lowercase, and then we reverse it, it will be the exact same string. And that's the approach I'm going to be taking. I'm just going to be removing, I'm going to be filtering all the useless characters from this, keeping the characters that we want, and then converting them to lowercase, then reversing the string, and then checking if it's still equal. So now let's get into the coding solution, at least the first coding solution. Okay, so now let's code it up. And remember, we're going to be building the new string, which is just going to be removing all the non-alphanumeric characters from the input string. So this solution is kind of the cheating solution where I'm going to be using a lot of built-in functions and extra memory as well. So we're going to just iterate through every single character in the string S. If that character is alphanumerical, and the good thing is Python, and actually I think most libraries, most languages like Java have a built-in function to check if a character or a string is alphanumerical. Python at least does, so we're checking if this character is alphanumerical. If it is, we want to include it in the new string. So we're going to go ahead and take that character and add it to the new string. But one thing you don't want to forget is we want to make sure that every character is lowercase. So before we add it to the new string, we want to make sure that it is lowercase. So we'll convert it to lowercase. And then we're done with that. We have the new string. We removed all the other characters from it. Now we just want to check if it is the exact same when it has been reversed. So we're just going to take this new string, compare it to the reversed string, which in Python you can do like this. This is the syntax for reversing a string. So if they are equal, then we can return true. If they're not equal, this will return false, which is what we want to do to determine if it's a palindrome. So now let's run the code and make sure that it works. As you can see on the left, yes, it does work. But there are some deficiencies with the solution that maybe your interviewer won't want you to use. Maybe they won't want you to use this alphanumerical function and they want you to implement it yourself. Memory without creating a new version of this string. And the main way is going to be by using pointers. So we're going to have two pointers, a left pointer and a right pointer. Because remember, there are multiple ways to check if a string is a palindrome. We don't have to reverse it. We can just compare the left character and the rightmost character. If they're equal, then we shift the pointers in. The left pointer comes here and the right pointer goes here. And then we can continue to check to make sure that the characters are equal. If they're not equal, then we return. But how do we know when to stop? Well, we're going to keep incrementing the left pointer and we're going to keep decrementing the right pointer until eventually they meet in the middle, or the left pointer, passes the right pointer, right? The left pointer becomes here and the right pointer is over here. That's how we know when we can stop. Or maybe they will meet exactly at the same character if the length of the string happens to be odd. Okay, so that's actually pretty simple. Not too bad. So what are we going to do? Okay, left is here, right is here. This is capital A, but of course we're going to convert it to lowercase. This is lowercase a, so they're equal, right? Okay, so then right pointer is going to be decremented by 1. So the right pointer is going to be over here at the M character. Left pointer is going to be incremented by 1, and it's going to be here. Well, we're at the space character. But remember, we want to ignore spaces. We want to ignore everything except for alphanumerical characters. And can we try to do this without using a built-in function? Well, let me show you how we can kind of do that. Basically, I did some quick Googling, and we're actually going to use ASCII values to determine if a character is alphanumerical. Basically, what you need to know is that each symbol, ASCII symbols, there's 128 of them, and do we? Because we want to skip this character, so how do we skip it? Well, we can create a while loop, which is at 57. So that's important, and we also have uppercase A starting at 65, going all the way down to 90, they are contiguous as well. And then eventually we can get to lowercase, starting at 97, going all the way down to 122. These are contiguous as well. Using this information in pretty much every language, you can write your own alphanumerical character detecting function, and I'll show you how to do that in a few minutes. But for now, just assume that we do have our own alphanumerical function and our left pointer is over here. What do we want to do? We don't really want to compare this character with the character M on the right side, do we? Because we want to skip this character. So how do we skip it? Well, we can create a while loop. So while our left pointer is not alphanumerical, then we're going to increment left, right? We're going to do left plus plus. We're going to keep incrementing left while it is not a alphanumerical character because we want to ignore characters that are not alphanumeric. So we're going to increment left one more time. Now, luckily, it is a alphanumerical character. It's the character M. So we compare left and right. They're exactly the same. So we continue with our algorithm. We decrement R over here, increment left over here. Right now they're both at the same character, and we're going to continue the algorithm. So that's the main idea. I won't run through this entire string because it's pretty long, but eventually the strings will meet in the middle. For example, over here somewhere maybe. At that point, we'll see, okay, they're at the same character, and then we'll say we can stop our algorithm. We've determined it is a palindrome, and then we can return true. So now let me show you how to code it up. The benefit of this solution, it is still a linear time algorithm. It's still big O of n because we have to iterate through the entire string, but the memory complexity is big O of 1 because we're not using any extra memory in this case. Okay, so now let's get into the code. First thing I'm going to do is write our alphanumerical function. So it's going to take in a single parameter, just going to take in a character, and then we're going to determine if that character is alphanumeric or not. How can we determine that? Well, I was using the ASCII values a moment ago, right? I was talking about them. So in Python, you can get the ASCII value of a character using the ORD function. We just want to know that the ASCII value of this character, if it is an uppercase character. How can we check that? Well, as I showed you a moment ago, ASCII values are contiguous for uppercase characters, right? So from uppercase A to uppercase Z, they're contiguous. So if the ASCII value of the C character, of whatever this character happens to be, is between the ASCII value of uppercase A and uppercase Z, that means it's an uppercase character. So that's good so far, right? That's progress. For now, we can check that this is an uppercase character, but we want to check if it's alphanumeric. So we have to extend this idea. So how about we say, okay, that or second condition, I'm actually just going to copy and paste this because it's going to be similar. We want to check if it's a lowercase character, right? Because that's the next thing. Is it uppercase or is it lowercase? We can do that by taking the ASCII values of the lowercase a and lowercase z. And last, it could be a digit from 0 to 1 or 0 to 9 actually. So let's do that same thing, right? Starting at 0, is it in between 0 or the integer 9. If any of these is true, this will be true. So basically, we've determined if it's an alphanumeric or not. That's what this condition will be. So we can go ahead and return this. So if it is alphanumeric, of course, this will return true. If it's not alphanumeric, this will return false. Okay, so we got our helper function out of the way. Now let's actually write the algorithm. As I showed in the drawing, we're going to have two pointers, left and right. Left is going to initially be at 0. Right is initially going to be all the way at the right side, so the length of the string minus 1. And remember, we want to continue the algorithm. We want to check if it's a palindrome while the left pointer is less than the right pointer. The pointers have not met each other yet or crossed each other. And so now we get to the point where we actually want to compare the characters. So we want to take the character at position left and the character at position right, and if they're...
I'm a little bit confused on the bottom because I know it's a helper function and takes in C. But the way I'm reading this is confusing me. It says return. I guess it's saying to return C. That's returning C only if it's between those. I just don't get how that syntax works though, like at all.
Not equal, we want to return immediately, right? Because if we find a single pair that's not equal, then we know it's not a palindrome, so we can return false immediately. But did we forget about anything? Well, the first thing we forgot about is we want to make sure to only compare the lowercase versions of each character. So let's convert this to lower and convert this to lower. So that's good. So if one of these is uppercase, one of them is lowercase, we're still good. But did we forget about anything else? Well, we never called our alphanumeric function, right? What if one of these is not an alphanumeric character? Well, we can't have that, right? We shouldn't allow that to happen. So before we even execute this if statement, let's make sure both characters at left and right are alphanumeric. So while it's not alphanumeric, so for example, while the character at position left is not alphanumeric, what do we want to do? Well, we want to increment that left pointer, right? So we can +1 to this. But one thing we want to make sure is that the pointer never goes out of bounds. So let's just add a checks to make sure left is less than right, for example. This will make sure that, of course, it never passes the other pointer, and it'll also make sure that the pointer doesn't go out of bounds. And we want to make sure to do the exact same thing for the other position as well, for the right pointer. So make sure that right is greater than left, and the character at the position right is, if it's not alphanumeric, then what do we want to do? We want to decrement the right pointer by 1 instead of incrementing. But both of these while loops will make sure that both characters are alphanumeric before we do the comparison, which is what we wanted to achieve. So then this will return false if it's not a palindrome. If the entire loop finishes, that must mean that the string is a palindrome, so then we can just go ahead and return true. Oh, and actually one more thing before I forget. After we do the comparison, we want to update our left and right pointers, right? We want to compare the next position. So to the left pointer, we're going to increment it by 1. To the right pointer, we're going to decrement it by 1. So just moving to the next position to do the next comparison on the next iteration of the while loop. So now this is the entire code. So let's just run it to make sure that it works. Okay, I was dumb. In Python, if you want to call another function inside of an object, you have to use the self keyword. So let's try that one more time. And as you can see on the left, yes, it does work, but it's actually slightly less efficient than the other solution, even though the big O time complexity is the exact same. And the memory complexity of this solution is actually better than the other one. This is no extra memory needed, as you can see. So I really hope that
Okay, so let's put a notion. Because I have to do this. I don't want to do it. I like, this is, let me show you all my thought process, right? Because I have to make sure I do this as authentic as possible. Because you know how YouTube is. People do certain things and they make it seem like it's just, well, you gotta do it. You gotta do it. Listen, even though you gotta do it, you may still not feel like doing it. Like, I'm looking at this, I'm just like, bro, I don't feel like doing it anymore. I just want to like, I want to memorize the fucking code, or it's just getting boring. It's like, no, I have to do the same thing that I did when I started, which was ask questions about this code. What confused me about this code? What are some things that I thought that was interesting about this code? This coding problem. Like, I have to do that. If I don't, I'm doing a disservice to myself. Because why am I doing this? Like, why would I be doing this? And sometimes I lose track of that. I'm just like, oh, this is for a job. I gotta get this. It's like, listen, you're trying to learn. You're just trying to learn. Let's do 2 pointers. This is very easy, so it's like I need to skin them down. You know? This. What am I looking for? 30 should have.
Hey everyone, welcome back, and let's that. How can we?
What I want to do is I want to get all this code already down. Code. I'm gonna write down. Stupid Python. Alright, and what we're gonna do here is we need 2 pointers. I'm just gonna write this down this way. See, there's no point in doing that. I'll just do that afterwards. So, some questions about this code. Header. Questions. And I'm doing this so I can get a better understanding for myself, you know. Y'all can't see it, but I'm writing down notes. I'm asking myself questions. And matter of fact, I'm gonna put it here. I'm gonna put it here so you guys can see, and I'll put the other thing here because I'm not gonna be really. Looks like I put them side by side, but y'all don't really need to see it. I'll put them side by side. But some questions, right? What are some questions? And when I say questions, not questions about the code and how do I solve the code. I mean questions on what you don't what you don't have, what you don't understand about it. So
Object, you have to use the self keyword. So let's try that one more time. And as I showed you a moment ago, ASCII values are contiguous for uppercase characters, right? So from uppercase A to uppercase Z, they're contiguous. So if the way, now let's actually write the algorithm. As I showed in the drawing, we're gonna have 2 pointers left and right. Left is gonna initially be at 0. Right is gonna compare the character. The algorithm, we want to check if it's a palindrome, while the left pointer is less than the right pointer. The pointers have not met each other yet. Or continue the way, now let's the character at position left and the character at position right, and if they're not equal, we want to return immediately.
yeah,
right? Because if we find a single pair that's not equal, then we know it's not a palindrome, so we can return false immediately. But did we forget about anything? Well, the first thing we forgot about is we want to make sure to only compare the lowercase versions of each character. So let's convert this to lower and convert this to lower. So that's good. So if one of these is uppercase, one of them is lowercase, we're still good. But did we forget about anything else? Well, we never called our alphanumeric function, right? What if one of these is not an alphanumeric character? Well, we can't have that, right? We shouldn't allow that to happen. So before we even execute this if statement, let's make sure both characters at left and right are alphanumeric. So while it's not alphanumeric, so for example, while the character at position left is not alphanumeric, what do we want to do? Well, we want to increment that left pointer, right? So we can +1 to this. But one thing we want to make sure is that the pointer never goes out of bounds. So let's just add a checks to make sure left is less than right, for example. This will make sure that, of course, it never passes the other pointer, and it'll also make sure that the pointer doesn't go out of bounds. And we want to make sure to do the exact same thing for the other position as well, for the right pointer. So make sure that right is greater than left, and the character at the position right is, if it's not alphanumeric, then what do we want to do? We want to decrement the right pointer by 1. That more thing before I forget. After we do the comparison, we want to update our left and right by 1. Then is Python keyword. So let's try that more time. And as you can see,
I don't get how he actually is checking. How checking? Because I get it's a helper function. Oh, there it is. I was so confused.
it's
Right there. Let me just keep that there. I guess I'll just keep these as questions. How does he loop through list? How list with integers? That's another thing. Like, how does he have access to S? Huh? When is he looping through S? How does he have access to string S? Well, left and right and not stuff. I'm trying to think. Oh man, it's code right now. Well, what we're saying right now is that R is at the end of the list. That one's at the front. That's what we're saying. So that means we're traversing it using indexes, right? That's how we usually do it. What I'm confused about
that right. So let's convert this to lower and convert this to lower. So that's good. So if one of these is uppercase, one of them is lowercase, we're still good. But did we forget about anything else? Well, we never called our alphanumeric function, right? What if one of these is not an alphanumeric character? Well, we can't have that, right? We shouldn't allow that to happen. So before we even execute this if statement, let's make sure both
skip over invalid characters. How does he actually use her config? the use of, and I think I was off mute the whole time, or on, yeah. And let's see this. So like some of the stuff I already know, right? Some of the stuff I need to be reminded of. It doesn't matter. It's practice. Practice, practice, practice makes absolute perfect. Um, okay, so um, uh, I'll all right. So looking at this, how can I write this out? Because this is the algorithm. I want to write down in words the actual algorithm. Initialize left and right pointer on at the front of the list. Okay. Condition. True. To traverse the sentence. Right? Right loop. Right loop. Check. Go.
so then we can just go ahead and return true. Oh, and actually one more thing before I forget. After we do the comparison, we want to update our left and right pointers, right? We want to compare the next position. So to the left pointer, we're going to increment it by 1. To the right pointer, we're going to decrement it by 1. So just...
I'm more confused on what that +1 means and does.
Is less than the right pointer. The pointers have not met each other yet or crossed each other. And so now we get to the point where we actually want to compare the characters. So we want to take the character at position left and the character at position right, and if they're not equal, we want to return immediately, right? Because if we find a single pair that's not equal, then we know it's not a palindrome, so we can return false immediately. But did we forget about anything? Well, the first thing we forgot about is we want to make sure to only compare the lowercase versions of each character. So let's convert this to lower and convert this to lower. So that's good. So if one of these is uppercase, one of them is lowercase, we're still good. But did we forget about anything else? Well, we never called our alphanumeric function, right? What if one of these is not an alpha character? Less than right, for example. This will make sure +1 to this. But character at position left is not alphanumeric. What do we want to do? Well, we want to increment that left pointer, right? So we can +1 to this. But one thing we want to make sure is that the pointer never goes out of bounds. So let's just add a checks to make sure left is less than right, for example, numeric. So let's just moving to the next position to do the next comparison.
Get that right there. So I'm gonna write this all down. Right equals 0, 9 s minus. Right. What we need to do is left is less than right. I'm able to alright. You know, if they don't equal each other, they can't be returned. So if s sorry, I'm a little out of it, a little sleepy. Apologize. It was just 38 minutes. So if that does not equal S, right, dot, dot lower, right corner, return false. False. Or that we actually want to do left, right. So yeah, this is my first time working it, so I don't need to understand it. I need to keep that in mind. I'm not meant to understand it. I am doing this so I can understand it. So don't need to worry about stuff I don't need to worry about. Like worrying about how to write this down right now is probably the least. Like, it doesn't hurt to try it. Like, it just, of course, it doesn't hurt to try it, right? At the same time, what that does is I'm wasting more time that can be used for me to completely understand. Because me trying to type it is not going to understand it. Right? Copy. Wow. Then we have all that. We exit this bar. We have r equals 1 plus 1 r minus 1. And then go to chat GPT. Let me ask this question. Why are we incrementing twice? Oh, I see. I know, never mind. I have to do this because it doesn't really tell me the answer I need to hear. Okay, so well, it's not an alphanumeric, this shows the point to enough. So it increments when it's not, and then this doesn't when it is. So I was thinking that. I see. I see. So I did. I think. I did. I did think that. That's interesting because if I had to code this myself, I would have gotten really confused because of the way he like coded it. Because you think of it kind of backwards, but that's what coding is. Um. Because but we want to compare them. All right, this is how we can. I don't get it though. Why can't it be used without that? That's just from so it is what I said. I'm just not completely understanding it. Um, I'm not completely understanding it. Okay, so this is about all that I got. And even though it was annoying, it was frustrating to go through it again, it is very important that I do this because it's the only way I'm going to learn these problems. No, there's no if, ands, or buts. No if, ands, or buts. Um, I'm not going to practice it. What I'm going to do is practice two some real quick. Put on the timer, and we're just gonna solve it. We're like none of the fucking like, we're just gonna try to solve it because I don't want to waste any more time. Two some, we know that we're going to have to return two indices. I need to at least run through the problem still, but like what we have is nums and targets, so what we're gonna have to do is look through nums and targets. So we're gonna create a dictionary to do that too. So pre that. And something with indices, I'm going to use a enumerate. For I, comma, and enumerates your I came in the room, so I was kind of multitasking. But let's see if we got this. Well, it's looking pretty good to me. For I and enumerates, I think this is for I and enumerate. For enumerates. I always think it's enumerates because you're constantly doing it, but listen, it's just a person, and we got it. That's actually now listen. This is where you give yourself the props. This is where I say good job. This is where I give myself the flowers, because despite it seeming like it's a very small task, this is that one small step, that one small step for man, one giant leap for mankind type feeling, because it's like this is what you start off with. It's going to get down and down, and I was doing that while talking to someone too, and it was kind of memorized, but it was kind of like I understand this problem at the same time. And of course, I'm going to keep practicing so I don't forget how to do this problem. So at the end of the day, there's software engineers that code all day, and they still may not be able to do this because they're not dealing with this certain type of stuff. So it's like, this is only for one skill set. This is for one scope. This is for me to get past the interview. And it's easy, yes. This one's very easy, but I solved it. I solved it. There was that point in time I couldn't solve it. And there's people who can't solve it. So the fact that I solved it, I can solve it now. It's just a +1. And I'm saying all this because you need to realize this. Like, when you are practicing something to get good at it, and you don't, no matter how easy it is, if you are able to accomplish that one, and then you go on to the next, you have to acknowledge that you accomplished it. You have to. As I use the restroom real quick. All right, we're gonna go for another hour or so. We're going to now practice. We're gonna practice other one, which would be contains duplicates. Contains duplicates. Really, really easy. So we're gonna see if it has it twice. All right. So we need a dictionary for this, right? And what we need to do is loop through. What do we have here? So we have to loop through it. We have to just like see if a number is a number. We're not messing with indices and stuff. That's what I'm trying to say. So we just do for num in nums, right? And what we have to do is if num in nums return false, right? So if we return false, it has a duplicate, right? That means we've accessed it twice. That means we've seen it before. And then here, we have to undo scene.add. So we just need to add it. Only for the exit for loop, we return true. So we have our dictionary. We check. We go through it, and we have num and num. So it's going to become 1, 2, 3. All right. So we have one. We have one. Right. We check if num. We check if num isn't seen. If we check if num isn't seen. If num isn't seen, we return false. Since not add num to seen. All right, we're gonna do it again. We have 2. We have 2. So if num isn't seen, which it's not gonna return false. It's going to just add it. So we have 1, 2, and then we have 3. If 3 isn't seen, which is not, we're going to just add it again. And then we have 1. If num isn't seen, right? Oh, num is already in scene. Just return false. That should be pretty much it. I'm confused on that. Oh. Scene becomes scene. Let me just go here, go to coding, and let me go to code 150, go to asset.add. using a set here. Set I can't. Set dot add. Set dot add okay, so I guess wait, why would it if n not in nums? Oh. So if it's not in scene, right? What does it mean if it's not in scene? If it's not in there, right? That means we can return false. But I thought we had to add it. Because we only want to add it if it's not in there, actually. So yeah, add it if it's not in there. Right? And if we keep adding them and it doesn't return. That's not right. That don't make sense to me. How does that make sense? I think this code. I think this might just be wrong in general. It doesn't make sense. It's also wrong. I'm glad, cause I'm just like, wait, what? That's crazy. I've been like thinking on it. That's wrong. So I don't want to add it here. If it's not in there, I want to add it, but it's gonna return false. Hold up. If it's not in there, right? Hold up. Oh. If it's in the hash set, if n in hash set, right? What do I want to do? I want to return it. Keep on adding to the hash set dot add. That's what it should be. I don't get why it isn't that. It produced false and expected true, which means it is duplicate. So that means, oh, let's do the reverse. True. False. Okay, that's cool. Yeah, and this one was just wrong. Like, I had it in there just completely wrong. It's very interesting. They definitely help. And last,
this is the creepiest power-up in anime, period.
You know how a lot of people are like, God help me. You don't need God to help you. What you need to say is, God help me get strong.
valid anagram. A a a. All right. So first things first, I'm gonna have to compare the length of these two strings. If I don't remember. If length S is not equal length T, we got nothing to talk about, right? We got nothing to do. Right? We're just returning